Okay, this is a video for integrated 2 for the probability review. This review was already posted on your daily agenda. I'm hopeful that you have started working on it already. This video really is going to be just going over the solutions in a very brief fashion. So make sure that you have read this question for yourself. We are talking about lunch menus, and we also have down at the bottom that the situation we're really looking for here is or. So be careful that you don't double count any boxes or any probabilities. So if I take a look at this, it looks like I have two different variables here. I've got protein and I've got vegetables. Because it's two variables, you can create a area model or a table, and or you can create a tree diagram. It's ultimately up to you. So why don't you pause the video now if you haven't already done so, see if you can create some sort of a visual for yourself, if it's helpful, and then come back and double check your answer against mine. Okay, taking a look at our table here and looking at the question, we find the probability that she will have fish or, okay, so let's talk about the fish first. So for fish, we know that anything in this row is going to represent a success for fish. So anything across there, which the total of that is going to be 1/4. So probability of fish, 1/4. Or, okay, green vegetables. Well, with green vegetables, there's a couple of different places that we could be. So we could be the peas, the broccoli. So those were our two green vegetables. So we would add the peas probability and the broccoli probability. However, if you take a look at the table, you see that we've got a couple of overlapping sections. So with those overlapping sections, we need to make sure that we don't double count those boxes, which we are currently doing. So where the blue and the green come together is being double counted. To figure out the probability of each of those, I'm going to multiply the 1/6 and the 1/4 probability. So it looks like we're double counting 1/24 twice. So we're going to go ahead and get rid of the 1/24 for the first double count and the 1/24 for the second double count. And then we'll go ahead and do the math and put these together, resulting in a probability of 1/2. And that's our first one. Okay, moving on to the next question. Same thing, read the question, see if you can actually tackle the problem yourself, and then come back and double check your answer. So since I'm flipping a fair coin 4 times, so I've got 4 different things happening, or 4 things happening, I can't create an area model for this. So I figure a tree diagram might be best. You want to make sure that you have 4 different flips though, knowing that we are talking about a fair coin, so you have an equally likely probability of getting a heads or a tails. And then from here, I know that multiplying down any of these branches, the probability is going to be 1/2 times 1/2 times 1/2 times 1/2, which is going to give me 1/16. So each branch is 1/16. So at that point, I just need to figure out how many of those branches give me exactly what I want. So I would go through and highlight each of those branches that matches what I'm looking for. So identifying each one of the ones that would be a success and knowing that each branch itself is going to be a probability of 1/16. Since it's going to be 1/2, 1/2, 1/2, and 1/2, I would just go through and figure out how many of these I actually have. So it looks like I have 6 of them. So the probability of exactly 2 tails, yes, 2 tails, is going to be 6/16. Okay, moving on to the next one. Same idea here. It's very similar, except for now we're doing at least 2 heads, and we're actually only flipping the coin 3 times. So see if you can set this one up and solve it and come back and check. So setting up this question the exact same way as I did the previous one, and then made sure that I had 3 different coin flips, and then you want at least 2 tails. So 2 tails would be a success, 3 tails would be a success. I found all of those probabilities, knowing that each branch was going to be 1/2, 1/2, 1/2, so that's 1/8, and then counted up how many of those branches there are, and there are 4 of them. Okay. Another question, now we're talking about dice though. See what we're actually trying to do here. You may need to set up a table, kind of like we did previously, or an area model, or you may not need a visual at all. It's ultimately up to you. So why don't you pause it, see if you can solve this problem, come back and check. So on this one, I decided to set up a table. Not necessary, but one way to do this. And then I numbered off each of my dice. So 2 fair dice, typically we're talking 6-sided, otherwise we would say. So then we've got 1, 2, 3, 4, 5, 6 on each die. And then we want to figure out what the sum is. Well, sum means to add. And since there weren't very many of these, I went ahead and just figured out the ones that would actually count as a success and then counted however many boxes that is. And it is 6 out of 36 total boxes. Okay, moving on to our next one. See if you can set up a diagram or a visual to help yourself out. Otherwise, see if you can answer the question without it. It's ultimately up to you. Okay, so for this one, I wanted to make sure that I read and figured out what was dependent on, or which variable was dependent on the other. Really, like, if he gets a hit, then that's because it was nice outside. Or was it the weather that helped affect whether he got a hit or not, so, or the baseball player themselves. So I went through, set up a tree diagram for this one. And since it did say that it was dependent on the weather, we wanted to go through and set this up so that the weather was first and then getting a hit or not followed up on that. Multiply down the branches, you should get the probability of a hit being 34% or 0.34. Okay, moving on. Same idea. Give the question a try. See if you can set it up. Come back, check your answer. This question's a bit more straightforward, so I went through, just created an area model for this, put the probabilities of each of the pencils and the erasers in the appropriate locations, and then I'm just looking for the overlap of the red-red combination, which gives me a probability of 2/6 times 2/3, which is 4/18. Okay, moving on to the next one. Now we have a table set up for us. We're going to use this two-way table. My recommendation to you whenever you have problems like this is making sure that you put the totals in the table as well. So the row totals, the column totals, and then the table total down in the bottom right-hand corner, and then see if you can answer the questions. Okay, so on the first question, I went through and did some highlighting on this. Plus, we need to specify a little bit more about, let's do under 20 years old. So probability of choosing soda C, that's the orange. That's going to be the 228 out of 800. And then we're going to add the under part. So that's going to give us 20 out of 800. However, there is an overlap in the table. So what we're going to need to do is make sure that we get rid of that overlap here. So if we take a look at this, that's the overlap of 126. Notice it's in that row and that column, so it's being double counted. So we want to make sure that we're going to go ahead and get rid of that. So just be careful when you're talking about or situations that you get rid of any type of overlap between them. Okay, so let's put the answer to A and then go ahead and move on to B and C. Okay, so here are our solutions for B and C. Remember, with the conditional probability, you are looking at a smaller grouping out of the entire sample that's been given to you. So we know these people have chosen soda A. So that means the population that we're actually looking for is the 326 total people. Of those 326 total people, how many were in the 60 and over age group? That's 141 out of the group of soda A people, which is 326. And then moving on, this is our last question. Give this a shot, set up a diagram, see if you can solve it, come back and check your answer. Okay, so here's our solution to the very last question. A little bit more practice than what we've been doing in class as well. Remember, we have our test coming up pretty soon. If you have any questions, make sure that you ask.